is an example of how we can use de Moivre's theorem to find the roots of complex numbers. So we have the equation z to the 6th equals negative root 2 plus root 2 pi. First thing I'm going to do is turn the right-hand side into polar form, since that will be easier to use our theorem with. And the modulus of this guy is 2, because I can see that it's 2 times the unit circle vector. So we've got a modulus of 2, and then that angle is negative positive, same sine and cosine, so that angle is going to be 3 pi over 4. So the right-hand side is 2 cis 3 pi over 4. Okay, now we're going to find one of the roots, and then we know that all 6 of the solutions, or roots, are going to be symmetrically spaced around the unit circle. Excuse me. And so if we would like to get those copies, we can also at this point add on 2 pi k, and that's going to ensure that we find all 6 of those solutions. Because going around 2 pi will again get us back to that angle of 3 pi over 4. All right, we're going to take both sides to the 1/6 power. That means we're going to take the modulus to the 1/6 power using the de Moivre's theorem, and now we're going to divide the argument by 6. Or multiply by 1/6, and the same thing that our multiples now are going to be 6 times smaller. So that means that our first solution, modulus, is still 2 to the 1/6, which, if it's not a calculator, we just leave it in that form, and then we can cancel this here. So our first solution, forgot my cis, is pi over 8. And then we're going to add multiples of pi over 3 until we get all the way back to something equivalent to pi over 8. Okay, and what this looks like on the coordinate plane is our first solution is at pi over 8, that'd be halfway between pi over 4 and 0. So here's our first solution, and then the rest are going to be evenly spaced around the coordinate plane. And so I'll do a few of the solutions and the same process applies. So we have cis pi over 8, our first solution. Second one, we're going to add a pi over 3. And with the common denominator, that would be 11 pi, 24. So here's second solution, first solution. For our third solution, we just keep adding pi over 3. Or equivalently, back up in our k notation, we're taking k equals 0, k equals 1, k equals 2. So now we have 11 pi plus another pi over 3, and that's 19 pi over 24. And we can continue in this fashion to get all 6 solutions.